We are back again, and like I promised, this time we will talk about the Newton's second law in terms of momentum. So what does Newton's second law have to say about momentum? Well, it says that the resultant force that acts on an object is equals to the rate of change in momentum of the object in the direction of the resultant force. Well, like the formula says here, it says that F net is equals to the change in momentum over the change in time. In the previous videos, we talked about what the change in momentum is. We said that when the velocity of the object changes, also its momentum changes. So, according to the equation of motion, I took it from here. Let me show you. The first equation of motion, this one here. I hope you can see there. This one that says Vf is equals to Vi plus a times change in t. So I wanted to solve for a, so I took everything to the left and divided by the change in time, and we know that a is equals to the change in velocity over the change in time. So we are going to Newton's second law of motion, which states that F net is equals to ma. So when we see a, we substituted what we got here, the change in velocity over the change in time. So we got that F net is equals to mass times change in velocity over change in time. But what is mass times change in velocity? We talked about it in the previous video. Is of course is change in momentum. So we get this equation here. The F net is equals to the change in momentum over the change in time. So again, Newton's second law of motion in terms of momentum. It states that the resultant force that acts on an object is equals to the rate of change in momentum of that object in the direction of the resultant force. You can tell by the formula here. Even if you forget the definition, if you write the formula, you can define it. It says that the resultant force or the net force that acts on an object is equals to the rate of change in momentum of that object in the direction of the net force. So just by writing the formula, you can explain that. So I just want us to do one or two examples and then conclude this video here. Excuse me, and yeah, let's do it. I hope you can see there. It says a boy kicks a ball to the right with a velocity of 10 meters per second. The ball hits a pole and moves back with a velocity of 8 meters per second. Oh, I think I skipped here. It says a boy kicks a ball to the right with a velocity of 10 meters per second. The ball hits a pole and is in contact with the pole for 0.3 seconds and bounces back with a velocity of 8 meters per second. Calculate the average force that the pole exerts on the ball during the time of contact. So what is happening here? This boy here kicks a ball horizontally to the right. This ball here will hit the pole. This pole here must exert a force that will cause this ball here to move towards the person who kicks this ball, which is a boy. So if this ball here, for example, if this ball here hits this pole with a force of 50 newton, then this pole here must exert a force of 50 newton in the opposite direction to cause this ball here to bounce back to the person who kicked it. So how do we calculate the average force here? Well, we know the formula, and we know that the mass of this ball here is 0.45 kg. We are given that here, and we can just use this formula here. The F net is equals to the change in momentum over the change in time. So you are given this formula in your formula sheet here. I will show you later, and Let's substitute what we know. We know that F net is equals to the mass times change in velocity, the mass V final minus V initial over the change in time. So F net is equals to mass, which is 0.45 kg, over what is the final velocity. Oh, before we do that, let's choose a positive direction. Let's choose to the right as positive, and everything that is going to the left is negative. So final velocity is 8, but because it is going to the left, we will say minus 8. So 0.45 minus 8 minus this velocity initial is going to the right, which is 10. So we'll say minus positive 10 over 0.3. So F net is equals to, let me take my calculator. So I will say 0.45 into minus 8 minus 10 over 0.3. So I get a value of minus 27 Newton. So this is the average force that this pole here exerts on the ball. So if they ask you calculate the force that the ball exerts on the pole, then it will be a positive 27, because this pole here must exert the same force on the ball but in opposite direction. I hope you understand that. And let's take a different example and then conclude this video. Let me do this here. Let's say here we have a trolley of mass 12 kilograms, and this trolley here is moving to the right with a velocity of 15 meters per second. Let me bring it closer there. It is moving to the right with a velocity of 15 meters per second. It moves from point X to point Y, which are 6 meters apart, and it stops on point Y. So what is the average force that this surface here exerts on these wheels here to cause this trolley to stop for a distance of 6 meters? So there are different ways you can do it. You can do it by F net is equals to MA. You can also do it by saying F net is equals to change in momentum over change in time. Let's see which one fits here. So we can find acceleration here. We can use the first equation to find acceleration. So we know that acceleration is equals to change in velocity over change in time. But here we do not have change in time, so we cannot use this equation here. What another equation that we can use is Vf squared. On your formula sheet, look for equations of motion. You will see this formula here. Is equals to V initial squared plus 2 times acceleration times change in x, or the displacement. So what is the final velocity here? Well, the final velocity is 0 because it stops at point Y, so its final velocity is 0. It cannot go even further, so it has a velocity of 0. So V initial is 15 meters per second. So it's 15, don't forget to square, plus 2a. What is the change in displacement? Of course, is 6 meters. And then we will see minus 15 squared, because we took this 15 positive 15 squared to the left, and it becomes negative. So it becomes 2 times 6, which is 12a. So acceleration is 15 squared over, let me take my calculator, negative 15 squared over 12, I get a value of negative 18.75, negative 18.75 meters per second squared. But we haven't answered the question yet. The question I want us to calculate the average force. So we will say F net is equals to MA. So we will say F net is equals to, we know the mass of this trolley is 12 kilograms. So we'll say 12, let me put it. So we'll say 12 times minus 18.75. So the F net here is in the opposite direction, times 12, negative 225 Newton, or you can say 225 Newton to the left, like this here, to the left, like this here. Another way you can do this is you can find time first. So let me do it over here. So you can find time first. You can use any equation. Let's say we use this equation here. The change in it's in your formula sheet, is V initial times change in time. No, I don't think we can use that. And yeah, since we have acceleration, I think we can find time there. So we can do this here. We can say acceleration is equals to change in velocity over the change in time. So we found the acceleration here. After doing this, we can say minus 18.75 minus 18.75 is equals to V final, which is 0, minus V initial, which is 15. I chose to the right as positive here, so over the change in time. So let's cross multiply here. We will have minus 18.75 times the change in time is equals to minus 15 here. So we can say that the change in time is equals to, let me use my calculator, minus 15 over 18.75. It's minus 18.75. I get a value of 0.8 seconds. So it's 0.8 seconds. You see minus 15 divided by minus 18.75, you'll get 0.8 seconds. And now you use your equation, F net is equals to the change in momentum over the change in time. So you say that the F net is equals to the mass, which is 12, times the final velocity, which is 0, minus the initial velocity, which is positive 15, over the change in time, which is 0.8. So the F net, I believe it should be the same as this. Let's verify that. So it's 12 into 0 minus 15 over 0.8, and look, it's minus 2 minus 225 Newton, or we can say 225 Newton to the left, like this here. So either two equations, they work the same, and formulas, they work the same. And yeah, I believe you could follow what I did here. And I want us to conclude this video, and then in the next video we will talk about the elastic collisions and inelastic collisions. So another way to, another term for the Newton's second law in terms of momentum, sometimes they might say the impulse momentum theorem. And yeah, before we conclude, let me show you this here. Well, we know that the impulse of an object is equals to the F net times the change in time. This is the formula for impulse. What is the formula for Newton's second law in terms of momentum? Of course, it's the change in momentum over the change in time. So let's cross multiply here and see. If we cross multiply, we'll get that F net times the change in time is equals to the change in momentum. But what is F net times change in time? Of course, it's an impulse. So we can replace this F net times change in time by impulse. So we can say that impulse is equals to the change in momentum. Like I told you in the previous video that the impulse of an object is equals to the change in momentum of the object. So here you can see. And one other thing that most students forget is that mathematically speaking, if A is equals to B, then B is equals to A. That means where I see F net times change in time, I can replace it with an impulse. And where I see impulse, I can replace it with F net times change in time. So according to the information that you are given, you can use either equations. So I will see you in the next video. Bye.